Hello, we're on to chapter 6 from this book. Help! Ah! Fire! Fire! More fire! More fire! It's gone. So, chapter 6, trigonometry number 1 from this book. Because trigonometry is so huge, they divided it up, so will we.
Yep, part 1 and part 2. This has been part 1.
You often don't get right angle triangles anymore. It's all about the different angles and new formulas for that.
We've got a few more rules. So we're at top left and right. So that's the cosine rule because of the cos A bit, and that's the sine rule because of the sines. And all of these there is lowercase and uppercase letters, and these mean something. So if I draw a triangle,
while I was doing that, I'm going to write out the next one without really talking much.
The capital letters, you can see they're associated with the sines, they're actually the angles. So if this was, this could be capital A, that would be there, and little a would be this side, and that would go around, this could be B.
So I'll make this B, so it's just the opposite side as the mini letter, the angle is the capital.
Yeah.
And you've got your cosine and your sine rule. You need to know 2 lengths of the lines and 1 angle to be able to apply this one.
Yep. And you need to know, well,
you either 2 lengths and an angle or 2 angles and a length.
Yeah.
These should be familiar from GCSE,
Yeah.
except now you use them all the time.
Got a few things to work out these triangles. You know you need to work out area before.
Yep. Area of this isn't as simple as base times height divided by 2.
Because these are all different angles, they're not none are 90.
So we have a new formula, a half little a, little b, times, is it sine or cos the big letter?
I think it's sine.
I think it's sine, isn't it? Sine, capital, the one that isn't here,
yeah.
So sine C.
That could be in any order.
Yeah. As long as these 3 are different.
You can't have to say this twice, but yeah.
And that's a new thing for working out.
That is a new thing for working out area.
Something else new, if you're using this you need to make sure this is in degrees if your calculator's in degrees mode. If it's not, there's something called radians.
And they're the things that's new, so we should get onto that.
We'll get straight onto that right now.
Alright, let's crack on. Okay, now on to using radians a little bit.
Yeah, so here we have an arc or a sector of a circle.
We do. There it is.
This angle could be measured in degrees. You'd have to convert it into radians for the equations we're about to go through.
Yeah, but it's an angle we don't know, we're going to denote that with theta.
Yeah, theta is often used to denote angles, if they're unknown. As this is a sector of a circle, these lines must be R.
Yeah, so that's
both be equal, they're both R.
Both radians. And you want to know this, to start with? It's called our arc length, and there's an equation for it.
We'll call it L in this case.
Alright.
So, I'll do it in blue, I think. L equals R
theta. Except theta needs to be in radians.
Yes, so on your calculator,
If you
rather than converting every time.
Yeah, which you could do, but it's better to just convert your calculator to work in radians instead.
You often go shift and go find the setup button. Some calculators are different models, but basically set up. You'll scroll down, it will give you
I think it says
an
DG.
angle, and you'll be able to change it into radians or gradians.
Yeah.
We don't bother with gradians, it's radians. Enter, and then you've got it in radians. Then sine whatever, cos whatever will be correct. If you don't,
then they'll be very wrong.
They'll be very wrong.
So then you just times that by that, and that'll give you that. That's quite a helpful thing. What if you need to find out the area of the arc?
Well, there's a whole new formula, very similar. I'll do it in red.
Okay.
So area we'll call A. A equals a half times R squared
Times
theta.
Same as this, where this would also have to be in radians.
Yeah.
That's it.
That's it. That is pretty much trigonometry 1. It's all about triangles and introducing the idea of radians. You actually use radians a lot more in trigonometry 2, but for now, let's go on to a test yourself, I reckon.
Okay, yeah, sure.
Let's do that.
Hello.
Test yourself. Page 85, question 1 and question 4 from this book.
Absolutely. Yeah, I'm going to read it out and we're going to do it. So the first question we're doing isn't actually from an exam, but it uses both the rules, so we're going to do it.
Yeah. So one.
It has a triangle,
Okay.
and the left side of the triangle is 3 centimetres, the bottom side is 4, and that angle is 52, and you want to find out the opposite side.
Now that might not look exactly like the triangle in the book, but I'm just doing it.
Yep.
A, B,
B,
C. So
and
what
you
are
want
we
to
gonna use?
find.
We want to find that, so I've got a big question mark
Yep,
there.
that's a good idea.
Okay.
I think we should use cosine rule.
Yep.
Why not there? So, write out the cosine rule. It is.
Luckily in this case, the little a, which is the subject of the formula, is what we're trying to find out.
It is. That's quite friendly. You don't have to re-note stuff.
A
This would be a squared, so or my a. But a squared equals b squared.
is 4 squared.
Yep. Plus c squared, which is 3 squared. Take away 2 times 4 times 3 times cos of a, which is 52. You could do that in radians, but it's in degrees, so I'll just convert your calculator back to if you need to.
Okay, I think
We could just do it.
just do it all in one go.
All up to the a squared, I think, and then we just have to square root at the end.
Okay.
Yeah.
So a squared equals on your calculator. I am in degree mode in my calculator.
Okay. So
2 times 4 times
Yeah,
3
of course.
times cos 52 equals that. I know that that equals 25. So 25
minus the answer.
minus the answer is that, and then so it's, oh sorry, you were doing that stage.
Yep.
10.22. And the square root of answer is 3.19.
A equals 3.19. We could just round it down to 3.2.
Yeah.
Centimetres. Yeah. And that's the answer.
Okay, so B, you're going to do B and I'll read it?
That sounds like a good plan.
Alright. Need a pen or have you got a pen?
I'll take your pen.
I'm going to take my pen.
Right, so
B is another triangle question. Now it's got a slightly upwards, slightly slanted line at 5 centimetres. The line coming down off that is 7 centimetres. The bottom left angle is what we're trying to find out this time, trying to find out an angle, and the bottom right is 36 degrees.
Okay.
That's A, that's C, and that's B in the question. Okay. So, we know 2 sides, we know 1 angle, we're trying to find out another angle. We're going to be using that up there.
yeah, use the sine rule. So you're gonna write with it before. So we have A, which we
Which is
No.
7 over sine. We don't know this, so we can represent that as sine theta, because that's the unknown, and that equals 5 over sine 36.
now you just need to rearrange it.
Yeah.
So,
I'm trying to picture it.
okay. So if we have 7 sine 36, move that over there.
36
And you want this to be over here. And you move the 5 under.
over 5 equals sine theta. Okay,
So you do that stage in a calculator.
do that stage in the calculator. Okay, 7 times sine 36 divided by 5. That is 0.823.
And then,
That equals sine theta.
to get that, we need to do sine to the minus 1 of that number.
Sine times 1 of answer is 55.4.
And that's the angle we're looking for.
Yes. Right, so we're now going to go on to question 4, so I think I should rub this off.
Okay.
Should I
I'll
give
take a
people
look.
just a second to have a look at it and move
Yeah.
to the side? So there's the answer to the first, 3.2.
And that's the answer to the second. Okay. Right, so question 4 uses the areas instead, well, the sectors and stuff with radians. The area of a sector of a circle of radius 10 centimetres is 75 centimetres squared. Find the arc length of this sector.
It's okay, I think I heard that. So it's
No.
a 10 centimetre radius, is
Yep.
it? And 75 in the middle.
Yeah.
75.
And there is an angle, but we don't know what it is.
We don't know the angle, and we're working out L, yeah?
Yep.
Okay, so this is at the moment theta.
So we've got 2 equations. So I think we should first write those down.
Okay, so we have a half r squared theta for the area,
Yeah.
for A, and r theta
for our arc length, and that's one we want to find out. But we don't have that.
So, but we do have that, and that, so we can work out that.
We can.
Then apply it. So, in blue, a half times 10 squared times theta equals 75.
Yeah, so we can rearrange that.
75 over a half r squared, well,
R squared is 100.
Half of that is 50, so it's over 50.
Equals theta.
So that's the same as 3 over 2.
It is. And that's in radians.
So I'll do that in green. This is 3 over 2. We now know it, I'm just putting it in.
Yep, we now know it, and then we can apply it to our next one. So 10 times 3 over 2, which is just 15.
Yep.
And that would be our arc length. Not that hard, but that one is an exam paper question.
Yep, is that 2002?
2003.
2003, there you go.
So this sort of question does come up. The other one wasn't an exam question, but we
But
did
it
it.
could come up, because...
Yeah, sort of thing.
And we chose to do 1 and 4 because we thought it covered
Covered
everything
everything.
we've done as opposed to some of it.
Yeah. Yeah, I think that's it.
We can go and sum up now.
Alright, let's do a summary.
Alright. So trigonometry 1
Yep.
of 2
Yeah, of 2. There is 2.
starts off with what you're familiar with in terms of trigonometry is triangles.
Triangles, but it then takes away the bit you like,
The
which
90
is
degree
the 90
bit.
degrees. You can no longer use Pythagoras. It introduces new stuff.
So we've got the sine rule and the cosine rule.
Yep.
A squared equals b squared plus c squared minus 2bc cos a is the cos rule.
Yeah,
Cosine
and the
rule.
sine rule is A over sine A equals B over sine B, and etc.
Yep. And then for finding the area, you can't do half times base times height, which you can with 90 degree ones.
Nope.
You
You
do
have
a
to do
half, little a, little b, sine, big C.
Yeah.
Or
whatever.
any rearrangement of that, basically.
Yeah, you can switch left to triangle.
We then introduced radians, which will come up a lot more in Trig 2.
We did, and they're a new idea. They're a lot nicer to use than degrees.
Yeah.
Their answers make much more sense, and you can use them in ways that are friendly, like the sectors and arc lengths. Which
So
we'll
that was
next.
a few new formulas. A half r squared theta for the area.
And r theta for the length.
Um,
That was it. Then we did a test self question.
something that combined everything.
Yeah.
Except area of a triangle. Unfortunately, we can't find a question that combines all of the triangle stuff.
No, but that bit wasn't very hard.
It wasn't very hard.
Yeah,
That's it.
that is it. On trigonometry 2.
Yeah, actually using random stuff. Not what you're familiar with when you hear the word trigonometry.
No, it's a bit strange, a bit graphy, but we'll get onto that.
We'll get on to that right away.
Alright, let's do it.
But for this video, been Wayne Leck,
James Trevette.
Trig 1.
Right.